Redundancies are when you have a zero row where all the values equal 0, or you have two rows that are the same value. In this case, you can get rid of it from the matrix altogether. Inconsistencies are when you have a row that says something that is false. Let's say, for example, the second row is basically saying 0 is equal to 1. That's not true. Then we have three basic operations we can use. The first is row replacement. Row replacement is when you can add or subtract two rows from each other, which in this case, in this expression, the first row that is written is the one that is changed. So row 1 is going to be changed by adding row 2 to it. In this case, you can see I add the elements of row 2 to row 1. Row interchange is just when you swap two rows with each other. So row 1 becomes row 2 and row 2 becomes row 1. Pretty straightforward. Row scaling is when you multiply an entire row by a constant. It can be whatever constant you want, but you want to pick constants that will help you cancel out other elements in other rows because you want this matrix in echelon form. Only when a matrix is in echelon form can you tell if it's consistent or not, because you can look at the number of rows and columns and compare them to each other, as you can see in the notes right here. Now there are three conditions for a matrix to be in echelon form. The first being that all the non-zero rows are above the 0 rows. As you can see in this example, the 0 rows on the top, we want to change it to the bottom. Now in this case, I do it in 2-row operations, but you can make it quick by just writing both statements on one arrow instead of having to write the matrices twice. Now in this case, this matrix is in echelon form. The second condition is that all numbers below a leading entry number are 0. Leading entries are just the leftmost number on the matrix of that row. Alright, now in this case, the number 1 in the first row is the leading entry. And that means there can be any number other than 0 below that leading entry. So we need to get rid of that 2. To get rid of that 2, we're going to multiply the first row by -2, because 2 plus -2 is 0. And then you can see as follows. Now we have this new matrix, and the new leading entry is the one to the bottom right of the 1, which is -4. -4 is our leading entry in the second row. Now notice there's a 1 below it. We can't have that. That's not echelon form. So to get rid of the 1, we're gonna multiply the second row by 1/4 to get -1, because -1 plus 1 is 0. And then you'll see me struggle on some math here, but just ignore that. Now in the third row, the only entry we have on the left is that constant that we had. And we don't have any more rows, so we're done. That is echelon form. The third condition is that in a row, leading entries are always to the right of the leading entries above. This is what I mentioned before with like a slide going down, like a staircase. See how this red line cuts through the main diagonal? Anything below that main diagonal has to be 0. And in this case, the 2 is below the red line. So how do we get rid of that 2? We're going to multiply the first row by -2, because 2 times -2 is 0. After we get our new matrix, we can see that the second row and the third row are completely the same. This is a redundancy, and we can get rid of either the second or the third row. It doesn't matter. We're going to have a new matrix with the same number of columns, but one less row. Now our new matrix has no zeros above any non-zero rows. The second condition is fulfilled. All the entries below leading entry are 0. And the third condition is filled. In a row, leading entries are always to the right. So this matrix is now in echelon form. Now in this example, we have this set of equations that give us this matrix. The first thing we can do is multiply the first row by 4, since we can notice that most of the numbers are 4. All right, after we do that, we can notice that the first row and the second row have the same numbers, just flipped. So what we can do is add the first row to the second row. And after we do that, we can get this new matrix. Notice how the second row is a 0 except for the one on the right. This is an inconsistency, and this automatically tells us that this matrix is not consistent. And because it's not consistent, this set of equations has no solution. In the second example, we have a new set of equations that give us a new matrix. This one is a little smaller and a little easier to work with. But we can notice that it's not in echelon form. We have to get rid of the leading entry below the 2 in the second column. To do this, we're first going to switch the third column with the second column because it has a 1. We want to prioritize rows that have 1s in already leading entry spots. So after we swap rows 2 and row 3, we get this new matrix. Now we want this matrix in echelon form, so we have to get rid of the 2 below the leading entry, 1. So to get rid of the 2, we multiply the second row by -2 because -2 plus 2 is 0. So after we do that, now we have all 3 conditions of echelon form are met. And we can see that this matrix is in echelon form and there are no inconsistencies that say anything is false. And since the number of rows equal the number of columns, on the left-hand side at least, this matrix is consistent and therefore has only one solution. If this matrix had had one more row on the bottom, that means the number of rows would exceed the number of columns, and that would give you a free variable, which means that there are infinite solutions, but we'll talk about that in another video.